So what happened is, um, we are going to talk about extrema. So we actually talked about mean value theorem before because I think it was shorter day. I want to talk about those, and but um,
Today's still short.
I know.
It's because of the mental health. Oh, you have later before. We do a mental health every few weeks on Thursday because why not? I guess. Yeah. So we had like 2.5 hours in your first period.
Yeah, this is my first period, so I was not aware of that.
Oh well, lucky you.
Yeah. I only give you mental health issues. I don't resolve mental health.
Honestly, one of my first thoughts today was, I wonder what it's gonna be like with Mr. Yeah. It's like that class sounds like it'd be fun.
Yeah, that class will be fun. I'm actually very good. Very good at helping people resolve their mental health. Believe it or not.
Surprising.
Not my homework, no. Not my tests, no. But on personal level, yes, I'm actually good people to talk to.
I thought the solution was just gonna be like, it's okay, you can miss this homework.
Your mental health state is undefined. That'd be a good way to talk about. Okay, so let's talk about extremas, and one of the theorem we didn't talk about is actually we did talk about extremal theorem, right?
No.
Extreme value theorem. Sorry, extreme value theorem. They say if f is continuous. Hold on a second. If f is continuous, okay, if f is continuous on closed interval, and this is a very idiotic theorem, I think. A and B, then f must have a maximum. And the minimum. Okay, so f must be have maximum and minimum. Let's talk about maximum and minimum, and so it has to be a continuous function on closed interval, and that's very easy to show you. The cases are not, right? So the cases are not, then you have to figure out, well, which case are not. They are gonna have are not. So why do I need to be a closed interval? So what if I imagine that if I have something like this, right? If I have something like this situation, like this, open circle like this. Okay. I have a minimum. Obviously, this is a minimum. But this is not a maximum because I don't define whether it's that's what 7.9 or 7.99 or 7.999. There's no way for me to define that maximum. Does that make sense? That's why you need to have a closed interval, and you have to be continuous the whole way. So this is not a maximum, or sometimes you can have a situation where the situation like this, let's just say A and B, I have something like it's not continuous, then this point does not happen to be a minimum, so it's not a minimum. So it has to be continuous. There's a maximum here, but there's not a minimum here because the lowest point is not low enough. We don't know how low is it. So that's why the extrema value theorem says it must be continuous the whole way. including the endpoints, including the A and B, in order for you to have a relative max and relative min. Now, in terms of a maximum and minimum, what I mean by definition of relative maximum and definition of relative minimum. So there are a few different type of maximum and minimum. So they are a relative min, and there is a relative max. But there is another type. This usually sometimes depend on the textbook. So a British textbook is going to call it local minimum, local minimum, or local maximum. There is also an endpoint. So sometimes your endpoint is the highest one. It's going to be endpoint maximum, right? There's endpoint minimum. So what if your endpoint is the lowest value, right? So that is going to be your endpoint minimum, right? But sometimes it can occur at the end. For first relative minimum, relative maximum, it must have an increasing then decreasing. So we're going to talk about that in a second. And there is also absolute max and absolute min. Okay, absolute is going to be the highest or the lowest in the interval. So you should consider endpoint and relative minimum and endpoint minimum and see which one's lower. If it's lower, then that's called absolute min. So absolute also has another name. It's in terms of IB textbook, sometimes they call it global. It kind of makes sense. One's local, one's global. Global is everything in the interval. And local is just small regional. So the regional, if you have go up and down, then there's going to be a maximum, or when you go down and up, then there's a local minimum or relative minimum. Okay, does that make sense? So I can have a situation like a graph, and I can have few things. So let's just say if I have a graph like this, that's between A and B. This point here is going to be a relative min, and at the same time it's also absolute min, because it's also the absolute, the lowest value. Does that make sense? And so this can be absolute min or relative. So they can be absolute in this case. And this one is going to be what?
Absolute and relative maximum.
Yeah, absolute and relative, right? So they can be absolute and also relative maximum. So when this maximum is go up and down, right? Now, can sometimes you have a relative min, but it's not absolute min? Yeah. Is it possible to have that? Yeah, definitely, right? So what if you have something like, I don't know, how do I draw it? Let me think about it. So sometimes you can have some situation like this is like this, right? This is absolute min, and also endpoint, right? It's also endpoint. But this one is relative. So it doesn't matter if it's relative, it doesn't mean they are the lowest point. You can have at the lowest, you can have the absolute minimum. So you should check when they ask you absolute maximum and min, you should check the endpoint whether they are the highest or the lowest. Not always you're gonna have the endpoint is gonna be the absolute min, but you have to check. You have to confirm that situations. You have to confirm that situation. So if I want to find the extrema on the interval, then I have to check both places. I have to check with one thing is called critical number. Do you guys remember what's critical numbers? What is critical number?
Derivative equals 0.
And
And endpoints?
no. There's two places critical number.
Asymptote?
Oh,
Yeah.
vertical tangent? No, not a vertical tangent.
You're not entirely wrong.
Asymptote?
Look.
When the derivative is undefined, is that right?
Yep. Two places. So let's talk about critical points. Okay? Critical number, sorry. Sometimes they use definition of critical number. And that's also a big one. Critical number. Critical number is when f prime of x is equal to 0. Or, people forget about this one, f of x, prime of x equal to undefined. Okay, so f prime of x equal to 0, but usually people forget this one. Don't forget. Right, don't forget. Don't forget that f of x can be equal to undefined, which is denominator equal to 0. Which is, that's what Logan said, you can have a vertical tangent. So two situations that you're going to see. You're going to see one situation in terms of graphing might have something like this. Right, between A and B, a vertical tangent. That's still a maximum. That's still a maximum. It's not the normal maximum look like, but you can have something like this, right? You can have something like this at C. So there was 2 points. This dy dx equal to undefined. And this one is dy dx is equal to 0. So you can, yeah.
Instead of just making it like like having to be differentiable for the EVT to work, they just said that f prime of x could also be undefined. Aren't those just interchangeable? Like, couldn't they have just said that?
What does EBT stand for?
What?
What does EBT stand for?
Extreme value theorem?
Okay, okay. EBT, okay. So instead of what?
In this case, for EVT, it doesn't have to be differentiable for it to work.
No, it doesn't. It never asked that. So
Right.
EBT says it's continuous only.
Right, and isn't that because the critical number can be undefined?
Yes, can be undefined. Yeah,
But
so
if
that's
you wanted to say that the critical number couldn't be undefined, couldn't you have just said that it had to be differentiable? Like, aren't those basically saying the same thing?
Can you say that again? I don't understand. Okay.
Okay, you wouldn't need the critical number to be undefined if you couldn't have undefined values if the function was differentiable.
Yeah, but we never say in this definition, the critical number never mentioned about EBT. It just what's the definition of critical number. So you don't have to worry about is EBT or not. EBT has no relevance to the situations. Did I answer your question? No?
Sure.
That means no. Maybe we are answering different questions.
I'm just saying that it's a, never mind, I'm not, I understand it, I'm just trying to think further.
No, I appreciate that. I think that's important that you're thinking, and I'm sorry I didn't get the question right away. So sometimes my language is not translate inside my head. So I'm like trying to like slow down the pace because I'm still had to convert the language inside my head. So sometimes it doesn't really register. I'm sorry I didn't answer the question. But yeah. But relative extrema only occur at a critical number though. I don't know if that helps. So relative extrema only occur at a critical number. They cannot occur at anywhere else. But it's a critical number always relative extrema? That's another question. Can a critical number being a relative extreme always relative extrema? Why not? Can you think about a situation that it's a critical number, but it's not a maximum or minimum?
Vertical tangent?
That's going to be a relative maximum minimum, just like this case, right? Just like this case, there is a relative maximum and minimum. But can you think about a case where is a critical number, but not a maximum and minimum? Can you think in terms of graphing? No.
Horizontal line?
Almost. Nicole, what are you gonna say?
Oh, I wasn't thinking graphically.
So imagine that you have something like this, right? Imagine that you have something like that. So we're gonna say, relative, right? Relative extrema only occur at critical number, right? Critical number. Sorry, critical number. Okay, so but it's all all critical number are minimum and maximums. No, Eva, what do you say? Which case is not relative maximum minimum where you have a critical number? That's just not continuous. How about a graph like this? How about a graph like this? Right? It has a horizontal tangent, but it's not relative and minimum. So if you have a critical number, if you have relative extrema, it must be a critical number. But if you have this one, it doesn't go the other way. It's kind of like a reverse. It doesn't go the other way. But we'll finish this lesson tomorrow. But we'll give you a worksheet about critical number. Basically, just say the derivative